What is up, Brian here from Ballistic Tech, and today we are back with part 2 of our video series on how to create your own DIY steering wheel. In part 1, which if you haven't seen, I recommend you go check out. We go over a high-level view of kind of all the different steps and components, the order you want to do things in, and we go a little bit into what we're going to talk about today, but now we're going to get much more in-depth in talking about front plates. So these are typically going to be most likely CNC'd or cut in most people's builds. So we're going to talk a lot about just the different options you have for materials, thicknesses, different services that you can use, different types of CNCing and laser cutting that you might want to check out. And in addition to front plates, some builds often have kind of like a rear plate, which you might also want to get made out of the same materials. And then finally, paddles are typically one of the most common elements that people like to try to do out of an aluminum or carbon fiber or even 3D printing. And as I mentioned before, all of these videos are going to be kind of based centrally around this. This is the Turn GTE DIY steering wheel. I bought the CAD files from Zach at Turn Racing. I'll have links to this and a bunch of other different assets from his website. It looks absolutely awesome, especially when it's completely finished. You might recognize it because it was on Sim Racing Garage where Barry reviewed it. And since we are talking about front plates, I will remind you again that Zach does have bare bones kits of this wheel and other wheels on his website. So they're an awesome way to start out, and they basically take away 90% of the decision making that you have to make that I'll be talking about in this video, because you'll get the carbon fiber cut plate. That's going to be a 5mm thick plate. You can also get optional polyurethane grips molded onto there by Zach, and his grips are really great. I think they use like a 70 or 60A shore rating polyurethane, and they feel really good. So you can also kind of skip the next video, which is going to be on grips. So I mentioned in the first video that your front plate is often going to be something that you want to decide on and plan out first, because it can impact a lot of other decisions you're going to make. And that's because the front plate in a lot of designs are kind of the heart of the build. They are what everything else gets attached onto, and a lot of the builds are also kind of going to provide most of the actual kind of rigidity of the wheel. It can kind of make or break the overall like aesthetics and feeling of the wheel. So it's kind of an important decision to make. There are a lot of different elements that you want to think of. Cost, the actual physical availability, can you get your hands on that material or that service? Ease of working with is something that you're going to also want to think about. You know, if you get carbon fiber in a blank sheet, you're going to have to cut it yourself, and that's going to be really difficult. The availability of info, you know, like maybe you have a CNC machine and you want to cut this material like aluminum yourself. You know, can you find out the speeds and feeds that you're going to need to be able to do that? And then finally, one of the biggest things is honestly aesthetics. You know, you're going to have options like aluminum, and you're going to have options like carbon fiber. You can of course wrap an aluminum plate or paint it with like powder coating or just some type of enamel paint, and you can get a good aesthetic there. But if you get a carbon fiber plate, you're going to start out with that nice twill pattern right out of the gate, so you don't have to worry about doing that. But carbon fiber of course costs more than most aluminum does, so you're going to have to balance out most of these factors, and we'll get more in depth to that in a second. So materials is one of the big decisions that you're going to have to make, and if you pick the right material or pick the wrong material in that regard, it could result in having a very flexy plate, or a plate that at the worst might break while you're using it, and you obviously don't want that. And then also there's the aesthetics, which I mentioned, and weight is a big factor in terms of the material. Carbon fiber, it's hard to get a hold of, it's more expensive to have cut. If the wheel that you're building is a replica and the real wheel is made out of carbon fiber, it's great to have a carbon fiber front plate. It just adds to the overall aesthetic. It makes it seem a lot more legitimate. Carbon fiber also has the great strength to weight ratio, so you can get a thicker piece of carbon fiber, get a really nice stiff piece of carbon fiber, and it's not going to be all that heavy. You know, the whole mass of your wheel is something that's your wheelbase is gonna have to spin around, and the heavier the wheel is, the harder it's going to be for your wheelbase to provide good force feedback. So if you're not on a wheel that is a direct drive wheel, you know, your wheel could start to struggle to give you force feedback when you're using your very heavy wheel. For cutting carbon fiber, I recommend you use the service unless you are extremely well versed in all the things you need to consider Carbon fiber dust is terrible for you. If you breathe it in, your lungs don't have really any way to get it out of your system like it can with other types of dust. It just gets scarred over and it's gonna be there with you forever. So the carbon and the resin are terrible for you. Carbon is conductive and carbon dust is very corrosive. So if you're cutting it and it gets into anything, if it gets on the electronics, it can actually cause shorts in some cases. And if it gets into, you know, anything that has any moving parts, it's gonna start to corrode that away. It's also very difficult to dispose of. You have to check your local region, state, you know, country and things like that to figure out you have this carbon dust. Even if you do something like a water bath to CNC it, you need to get rid of that material. So that's something that you really need to think about. I don't recommend you cut it yourself. If you do have a setup that's capable of cutting it with good dust collection, make sure you're well ventilated, make sure you wear the correct PPE, you want gloves, you want a respirator. You just do not want this stuff getting inside of your lungs. And it's worth noting that not every single race car steering wheel uses carbon fiber. A lot of them just use some type of aluminum or other metal. So, you know, you don't have to worry about not having that carbon fiber twill pattern on it. For aluminum, it's also a great material. You can hand cut it, you can get it cut by a service. A lot of services can handle aluminum, including SendCutSend. So the turnaround times are pretty fast because they don't have to worry about figuring out new speeds and feeds, and the setup costs are generally fairly low as well. It doesn't have as good of a strength to weight ratio as carbon fiber, but you can get away with using a slightly thinner thickness of aluminum and maintain the rigidity, even though it's going to be a little bit heavier. So the same thickness plate cut in aluminum and carbon fiber, I found that the aluminum one tends to be a little bit more stiff. Aluminum is usually a metallic silver color and your wheels might not be, so you can paint them in a number of ways. You can also wrap them, but I've seen people powder coat them. You can also paint it with a like an enamel type paint. You do want something that's not going to chip away all that easily. Another option is acrylic. If you get acrylic in somewhere around 4 to 6 millimeters, it's going to provide a good amount of rigidity. It is usually going to be clear or kind of like a weird opaque, so you might want to paint it or wrap it, but it's going to provide a decent amount of rigidity for its weight. A couple guys on the Turn Discord have used acrylics for their front plate and seem to like it just fine. It can be CNC'd, it can be laser cut, so some services might be able to do that for you as well, but it's an option. I haven't used it much for this specific purpose, but definitely check out and don't sleep on acrylic. So I'm gonna mention wood. I've seen a couple people build all wood wheels, kind of have like a interesting, to me, boat aesthetic. I don't know how else to put it, or like an old school kind of like Aston Martin or something like that. For a front plate, I can't really think of any wood I would definitely recommend. There are harder, denser woods like MDF or different types of density fiberboard that might be suitable. They're oftentimes millable, so you could use something like a CNC, but I'd be afraid of the amount of flex that they would show. You can maybe get a multiple ply piece of wood that's 5 millimeters thick, which, you know, has different crossing of the grain, so it would provide a decent amount of rigidity, but I don't have any experience in that, and my first thought would be a piece of wood like that would be so expensive you might as well go with aluminum. So in terms of pricing of raw sheet material, acrylic is usually the cheapest. A 5 to 6 millimeter thick sheet is going to be in the range of $15 to $30 USD. Next up, we have aluminum. A similar 5 to 6 millimeter thick sheet is likely going to be from $25 to $40. And then lastly, the most expensive is going to be 3K twill carbon fiber sheets. A sheet of this at 5 to 6 millimeters is going to cost from $35 up to like $110 in my research. Prices will of course vary based on your region, the retailer, and the quantity that you're buying. But that should give you a good idea of what the stock will cost you if you want to cut a front plate on your own, and how much of your money is kind of going towards the stock when using a service. Note that services are likely using a larger piece of stock and cutting multiple pieces at once. And they're also getting different wholesale rates, but you can still do your own research, find some prices, and it'll help guide you as to whether or not you want to cut your front plate or use a service. So 3D printing, is it viable for a front plate or a back plate or paddles? I'm gonna go ahead and say that depends. A few things you might want to consider is your wheelbase. If you have a very strong like direct drive wheelbase, if you have like a 5mm front plate in your build that doesn't have a lot of structural kind of rigidity coming from any other type of area, then probably not going to be strong enough. It's going to flex and possibly even break. When you hold on to a front plate, when you're actually putting, you know, turn and lock into the steering wheel, you actually do tend to kind of torque it a little bit. So here you can see that this is a 5mm 3D printed version of the Turn GTE front plate, and it is, I think, 65% infill and 7 perimeters. So, you know, that's pretty beefy. If you go very high on the infill, eventually it starts to kind of have diminishing returns, so the increased weight isn't providing all that much more rigidity and or strength. So you can see that this exhibits a fair amount of flex. Some of that will be alleviated by the extra parts that would be put on the back. So if you have a wheel that has a giant enclosure that covers the entire back of the wheel and provides some rigidity, it's a little bit more viable. But if you have something that's kind of like a DTM style wheel, kind of similar to the GTE wheel, then you're basically only going to have a hub on the back of it, maybe some button covers and button inserts, and then a lot of that stress is going to end up on kind of these two parts, which you can see are the thinnest parts of the front plate. So if you have a lower torque wheel, something like a Logitech G29, G920, G27, G923, those only have 2.2mm of torque. So a 3D printed front plate might work out, again, depending on the design. Some of the lower end Thrustmasters, their entry levels like the TMX and T150, I think you can get away with it too. When you get into the higher end of Thrustmaster and moving into Fanatec and of course the direct drive wheels, which cost a lot more, then I would be a little bit more hesitant. It's obviously something you can try. The great thing about 3D printing is that you can prototype and do things very quickly. I can get one of these front plates printed out in a day, whereas some of the services and things like that you have to send off to are likely going to take up to a week. I already talked a little bit about the design of the wheel, but that's obviously going to play a factor in whether or not you can get away with the 3D printed front plate. Some are kind of specifically designed to be 3D printed and have a structure that adds more rigidity. In the end of the day, you can likely print out a 3D printed front plate and use it as a template, and you know, you'll get an idea of whether or not that's something you want to use, and then you can get you know, a plate cut by another service. So I did want to quickly talk a little bit about carbon fiber infused filaments. I've seen a lot of people asking questions about them on the Turn Racing Discord. You know, is it a more viable option for printing something like a front plate? And I'm gonna say yes and no. A lot of people think that carbon fiber infused filament is inherently a lot more stronger than regular like PLA, but that's not necessarily the case. I'm pretty active in the like 3D printing community, going to Maker Faire, Murph, Earth, and I went to some filament manufacturers specifically to ask those questions. And the biggest thing they noted is that carbon fiber doesn't drastically increase the strength of a part. You know, if the same part is printed in carbon fiber infused versus non-carbon fiber infused, it's not drastically stronger like a carbon weave is. That's because a carbon weave has long fibers which are interwoven, and that provides a lot of strength. Carbon fiber infused filament has a lot of those same chipped fibers throughout it, so it can help with layer adhesion. The carbon also helps with kind of rigidity, which is obviously a good thing. So here we have a front plate that's actually designed to be printed in 2 pieces, and it's in a carbon fiber filament, and it does exhibit quite a bit more rigidity than a 3D printed front plate out of a standard PLA, but it's not drastically more strong. So it's likely going to break at around the same forces. And the thing about carbon fiber and carbon fiber filaments is they're often quite brittle. So when they break, they don't tend to kind of like fold in on themselves and compress or stretch. They absolutely snap, which is not something you want to have while you're, you know, driving your direct drive wheels. So it can exhibit better rigidity, better temperature resistance, less shrinkage, and better layer adhesion, but it's not overall just going to be like 10 times stronger for the same weight and material. It's also a little bit more expensive, so I've printed this wheel and I was fairly happy with it. This wheel also has a large enclosure which goes on the back of it, so that's kind of an ideal situation for a 3D printed front plate. If 3D printing is not something you want to go with, either because you're not sure if it's going to provide enough strength, or you don't have access to a 3D printer, the other option is going to be likely some type of subtractive manufacturing where 3D printing is additive. And in subtractive, you're going to start out with some type of stock and you are going to basically cut away at it until what's not a front plate is gone and what is a front plate is still remaining there. So some of these subtractive manufacturing processes include laser cutting, which is an option that's becoming more widely available, a CNC machine, which is also becoming more widely available. A lot of desktop CNC machines can cut through materials like aluminum, and some can cut through carbon fiber. Then you also have water jet machines, which aren't so readily available in a consumer form, but there are some services that do all of these. And then the last one, kind of the most low tech, is hand cutting. So one thing Zach does provide is DXF files and templates in the form of a PDF. So for hand cutting, what you'll be able to do is get a material that that you can cut. You can look that up, and I'll talk about it in more detail, but you can cut out that template one-to-one, glue it to the surface of whatever you're gonna cut, and then you can drill a pilot hole with some type of a drill that's wider than whatever blade you're gonna use. Then you can use either something like a hacksaw or a coping saw, or if you have one, a scroll saw with a metal cutting blade, and you basically cut out all the different elements that you don't want there. You can then also use something like a drill press to do any holes that might be in there, and you don't have to do just holes that are for screws. You can also do larger holes that are just like removing material. For instance, the holes in the handle or the holes for a button. You can usually find a drill bit that's going to be around that size, and you can basically get the same thing that you would order from a service done by hand. It's likely going to be a little bit more rough around the edges, so you'll want to take something like a file and file down the edges, especially in the places that you're actually going to be making contact. Try to get them nice and round and looking as aesthetically pleasing as possible. You can then do something like, if you have a router table or a hand router, you can get a round over bit to go over the edges, just to give them a little bit of a round over so your hand doesn't rub up against them whenever you have it there. And that's a perfectly good option. As I mentioned, you can then take that and wrap it with a carbon fiber vinyl. You can also just paint it if you want to with something like, you can powder coat it. Those kits are becoming more readily available. I think you can get a powder coating kit in an oven for less than $200. So if you're going to be building lots of wheels, that's an option. There are also powder coating services. I checked around me and it was going to be around $25 to get one front plate powder coated, and whether or not that's worth it for you, you can decide. You can also get high temp enamel type black paints from a hardware store. That'll be good, especially if you're going to end up wrapping it. So yeah, don't forget about hand cutting. It's a great option. You can do it with aluminum, you can do it with acrylic. So for some of the other subtractive manufacturing processes, laser cutting, CNC machining, water jet cutting, if you have one of those, if you have access to it, either because you're a maker and you have it, or you have a maker space or a guy with a shop near you that will let you use it, you're gonna have to figure out the speeds and feeds for the particular material. A lot of people think you can just shove a file into a machine, tell it to go, and it's just going to cut a plate perfectly. That's not typically how a lot of CNCing and even like laser cutting can go. You have to be able to dial in what's called the speeds and feeds, the speed that the actual CNC can move at, and the speed that the spindle needs to spin at, the type of bit that you need. You might need multiple types of bit, so that's going to be on you. I'm not a CNC channel, so I don't know a lot of that. I think there's a channel called NYC CNC, and they have a lot of tutorials, so that's something you can check out. There are some desktop CNC machines like the Shipoko and the X-Carve. X-Carve just came out with a new high-end one that's supposed to be very, very good for being able to print metal. People have done mostly printed CNC machines and other types of DIY CNC machines which can cut metal. So I'll leave that research up to you. So cutting services, what do you need to know? What do you need to think about? There's cutting services that you can find locally, you know, a guy with a machine shop around the corner. There's more regional ones, there's national kind of level ones that can ship across the country with faster turnaround times, and then there's international options as well. One thing to know is that services are gonna take longer than 3D printing or hand cutting one yourself. You've got to get a quote from them. Some places like SendCutSend, which I use a lot, have an instant quote system. So you upload a file, you pick a material and a thickness, and they immediately are gonna tell you exactly how much it's gonna cost. So you get that instant feedback of, yeah, that's within my budget, or no, that's a little too pricey for me. Maybe I want to hand cut it. But to other places, you send them an email with a file, you wait several days for them to get back to you. They ask you about the file and to make some changes, or say they can or can't do something, and then you make some changes, send them another email, and you know that can go on for several days or up to 2 weeks in my experiences. Services that are international, like several services in China, that is going to be even longer, and then the shipping is also going to take up to a week and be more expensive. So those are the things you need to think about in general. I have really come to like SendCutSend because they're in the United States, so they're in Las Vegas, I believe. They've got those instant quotes. They've got a good selection of materials, from stainless steel to aircraft grade aluminum like 6061, and they actually just started offering a carbon fiber cutting service. Now at the moment their carbon fiber is limited to 3 millimeters. It is a good option for things like button boxes. If you have a design that gets a lot of reinforcement from other places in the wheel, like the enclosure, then a 3 millimeter front plate can, you know, be fine, especially with carbon fiber, which is much more stiff than 3D printing. And I have talked to the guys at SendCutSend to give them an idea of, you know, what we're looking for as DIY wheel builders. Typically we want something around 5 millimeters thick, so I mentioned that we like to have things like pockets cut in so that we can recess different types of components, and at the moment they don't offer that because they just started up, but it is something they're going to be looking to do in the future. So if you get some metal plates cut from them, keep an eye out for them in terms of their carbon fiber cutting materials. It might be exactly what you need right now, and then also down the road it might be a great option for you. One thing you will need to check on for the services that you might want to use is whether or not they are a cutting service or they are a CNCing service. A cutting service just uses something like a water jet or a laser to cut a small little kerf or like slice of material away, and then this interior piece just drops away and you're left with something like this. A CNCing service uses a type of end mill to go through and basically just pulverize and chip away every piece of material that you don't want. So those have different types of elements they can do. A CNC machine can do things like pockets. It can also do things like countersinks, counter bores, chamfers, fillets, roundovers, and things like that you won't be able to get from a laser cutting service. But if you get something laser cut, you can do some of the more simple things like countersinks and counter bores with just a drill or a drill press. So that's something to think about. Just make sure that you don't expect to be able to send a laser cutting service a 3D file and get 3D features cut. That's just not going to happen. A note on carbon fiber cutting and CNCing services. These are going to be the hardest for most people to be able to find. A lot of shops just aren't set up to deal with carbon fiber. They're likely going to be the most expensive because it is difficult to deal with it. The material is usually a little bit more expensive, but not too much more expensive than something like an aluminum piece. The turnaround times are likely going to be a bit longer, and getting special features like pockets and stuff like that might be a little bit more difficult. For cutting services, the price will vary quite a bit based on the material, type of cutting, say laser cutting versus water jet versus CNC, and whether you're doing any type of 3D features like pockets, chamfers, etc. One thing to note is that requiring multiple tools for CNCing will usually increase the price quite a bit, as the setup costs go up when multiple tool paths come into play because of either manual tool changing, or even with automated tool changing, a technician is still going to have to look at the job and pick the best end mills for the different features. I've seen some acrylic cutting services that will do a 5mm front plate and 3mm paddles for as little as $35 to $40. Again, the most economic. I've shown you a 3mm laser cut piece of aluminum from SendCutSend can be as inexpensive as $45. A 5 to 6mm aluminum plate is only around $60, but again, consider the weight to strength and flex ratio there. You might be able to get away with a 3mm plate. I've been quoted aluminum plates CNC'd with 3D features for around $75 and as much as $150. And for carbon fiber, it's of course the most expensive. A 3mm plate from SendCutSend is around $140 based on their current capabilities. I've talked with some Chinese services and been quoted around $100 for a 5mm thick Turn GTE front plate, which is good, but again, the turnaround time and shipping time is going to be fairly long, and with many of those, they had a minimum order quantity of at least 5 to 10 pieces, which of course was a deal breaker for me just building one wheel. The best pricing I've gotten so far for carbon fiber cutting has been CNC Madness, a shop in Canada that specializes in drone frames. And talking with him, he believes he can keep the cost of a single front plate and paddles to around $100, which is a good deal. But I think all of that puts things into perspective when considering options. And to me, that makes Zach's bare bones kits even more attractive, considering the fact that you can get a 5mm plate with grips for around $150, which is less than getting just a plate cut by some services. But you do have some options. Do some research, ask local shops and see what you find. And if you find a good service, leave a comment below and I will pin it so that other people can see it. Picking a thickness, different services are gonna have different thicknesses. Different places that you're gonna buy stock from are gonna have different thicknesses. I already mentioned that you're probably gonna wanna pick your front plate first. And a big reason for that is the thickness of your front plate and possibly a rear plate is gonna dictate things like the length of screws that you need. A lot of grips kind of have a little bit of a recess in their design, and that's designed for a specific thickness. So if you get a thicker or thinner front plate, then you might need to adjust the offset and the recess. And that's one great thing about Zach's files is that he does give you the step file. So if in his step file he has a 5mm plate and you need to go with a 3mm plate or a 6mm plate, you can just extrude that surface in the direction you need and print it or however you're gonna have it produced, and you'll be good. So that thickness, you wanna figure out what it's gonna be, and if you swap, you know, if you go from one thickness plate to another one, maybe a different material, just remember that your screws and your grips might be impacted by that. Lastly, a quick note on some of the other pieces that are typically CNC'd, like paddles and something like a rear plate. You can pick the same material, you can pick this different material, you can pick the same thickness or a different thickness. Usually something like a 3mm or 4mm paddle is going to be good out of carbon fiber. It won't exhibit too much flex. If you have a very, very long paddle, like something out of the Turn GTE, 3D printing this can actually exhibit a fair amount of flex. So if the shifter arm is down here and you're pulling up here, you can get a little bit of flex before it actually actuates. There is a little bit of a risk of it breaking, but I'd say 3D printing for paddles is going to be likely perfectly fine. For the rear plates, again, you need to really consider the thickness in terms of the length of screws that you need to use. I had a 3mm thick rear plate that I was using, and then I switched to a 5mm plate, and then my screws ended up not being long enough, and I just hadn't thought of that. But that is it for this video. That is everything I can think of to tell you guys about in order for you to figure out what you want to make your front plate out of, the materials, thicknesses, surfaces that you can use, processes that you might want to use or consider having done by someone else. I hope you enjoyed it. I hope you learned something. I'll have links to as many things as possible in the description. I'll also have a link to the Turn Racing Discord, where we have a huge list of resources, including services where you can buy materials and things like that, plus all just the knowledge of the community in that Discord server. It's a really great community, and as people figure out new services like, you know, SendCutSend having carbon fiber. We discussed that in the forum, and just spread as much information as we can. So stay tuned for part 3, where I will be talking specifically about grips. I mentioned them here in terms of how they interact with the front plate, but I think a lot of people kind of skimp out on the grips, and it's something I think you should probably put a lot of thought into, because it's what you're holding on to the wheel with the most. So thank you guys for watching. I hope you subscribe. I hope you like the video, but if not, that's cool too. I'll see you in the next one. Peace. Blah, 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 blah.